Okay. Hello, everyone. Welcome to Concordia University's Forest Space. Thank you so much for joining us for today's event, AACE 3+1MT Construction Elevator Pitch Competition. That's the Association for the Advancement of Cost Engineering. And the 3+1MT is minute thesis, 3-minute thesis plus one explanation at the end. Now, just to help situate you, we are streaming to YouTube live from Forest Space. We also are located here on unceded Indigenous lands in Tiohtià:ke, Montreal. Here at Forest Space, we work with our university community to help mobilize knowledge by co-creating daily activities, examining research, questions, and projects happening all across the university. We're running today's event as a live stream Zoom meeting also, so there may be some of us joining there. If you have any comments, you could throw those into the chat. Those of you here in the space, this will be primarily for the judges. You have a microphone there on your table, and the rest of you will, I don't know if there's a Q&A necessarily at the end, yeah? Okay, there will be that too. We'll be passing a microphone around anyway so that people can hear as well. Okay, enough from me. It's very much my pleasure to hand it over to one of the co-organizers of today's event and a PhD candidate in the Department of Building, Civil, and Environmental Engineering, Shrouk Garib. Shrouk, it's great to have you back.
So first, I would like to thank you all for coming here today for our 7th, actually, AACE Montreal section presentation competition. So we call it the elevator pitch competition because each contestant, they pitch their PhD master's thesis, they explain everything in just 4 minutes. So to start off first, let me talk about AACE actually. So we're saying it's the 7th annual anniversary. That means we've been having it for 7 years so far. It's not the first year. Every year we do different things. We used to have it online, but this year is very special. We are featured as a competition for the colloquium CSCE student presentations. So not only, but we are having the International IR Conference, which is happening all the time across the world. This year it's happening here in Montreal, Concordia University, along with the CRC CSCE, which is a construction sector for the CSC, and the MOC, which is the Modular and Offsite Construction Conference as well. To start off, we mentioned that we're having a 7th year. This year, it's in person. All the presenters are in person, and this is actually organized by our amazing committee members, so who we are, actually. So these are our agenda for today, first of all, so moving forward, please. General housekeeping, that we want to make sure that everything is done. Please make sure everyone to write down your questions after each presentation. You don't want to forget it. We want to collect the papers afterwards. Just get it out, write the presenter name so you don't forget who is the person you are actually talking to. And we would like to thank our VIP guests that are coming from Hydro-Quebec, University of Florida, Calgary, Pomerleau, and others. Okay, now we have our academic advisors that we're able actually to push the whole thing and like help the committee to be better and better. Dr. Mazdak Nikbad, which is the associate professor in the construction here in Concordia University Department, and he's the associate dean for research and innovation. And our second academic advisor is Dr. John Ma, which is an assistant professor here in the Department of BCEE, and which is Building Civil Environmental Engineering, and he's the founding director of Aton Lab. And then our beautiful committee, which are amazing team who are able to get this actually event done. So first, it's me, PhD candidate, as Craig mentioned, here in Concordia University Building Engineering. I'm the president. Our VP and financial director is Azadeh Sofibor. Our operation director is Amr Alam. We have Minna Hammam as the marketing director, Muaz Al-Kabalawi as logistics, and Ihab Al-Husari as a planning. And then we have amazing 3 volunteers. Actually, one of them just joined us to help us just get done with the event. Literally, we can say less than a month, and she did amazing, which is Atifa, as well as we had Hosna with us for 2 or 3 months, and Shaheen El-Zaman. Okay, so we have our competition judges are divided into 3 sectors. The first part starts with the academic side, which is Professor Carl Haas from University of Waterloo. Can we just, sorry, can you like, thank you so much. And then we are having the second part will be our industry, our sponsors, our amazing sponsors. So we have Julie Gravel. She's a business development engineer from Canam Group. Okay, and the second one, the long member with the AACE, our helper, our amazing supporter ever, who's been helping us since the day actually started, Les McMullen, Managing Director of Project Controls and Technique PMC, ex-Hatch. And now our main committee, the AACE, the Association for Advanced Cost Engineering, the Montreal section, our representative is Hajir Omrani from WSP. He's a senior vice president, and he's been the president for some time, though he's giving the torch to someone else now, but he's still the same, helping us as he is still the president for the AACE. Please welcome Hajir. And now it's the founder of the AACE, the helper, the honorary, and he's the most amazing person ever, my supervisor, the founder again of the AACE Montreal Steering Committee, and long member in AACE, Professor Osama Mzlahi. Please welcome him.
Again, good afternoon, everybody, and welcome to the 7th AACE 3+1 competition. As we're proudly say that this was initiated by our grad students in the area of construction engineering and management in collaboration with AACE Montreal, really to do 2 things: promote and acknowledge excellence in research in construction engineering and management. So again, let me begin by expressing my sincere gratitude to the organizers, the judges, the sponsors, and all of you, the volunteers who made this event happen and make it possible. I had a list of names, but I think Shuru had them all of the steering committee and their volunteers, so there is no need to repeat. But also I would like to, and also the judges, but maybe the sponsors. We're gonna say the sponsor, that was maybe missing a little bit. Canam Group, thank you so much for Canam, and Julia is representing Canam today. Techni, project management consultants, and Les is here representing them today. And AACE Montreal, Hajir. Thank you all very much. The floor is yours. Start the competition and enjoy yourself.
Thank you so much, Professor Mzahi, and thank you again all for being here. Now I'll pass the torch to Dr. Mazdak, our advisor. Please welcome him.
Okay, thank you very much, Shuruk. Hello, welcome everyone to Concordia and to Montreal. This event is very near and dear to my heart. It's my 6-year-old kid that is now growing. I always mention this, but I can't stop mentioning it. 7 years ago, presenting the idea to the committee, including Les and Hajir. This was among some other ideas, but this one was the winner, and we have now this, I think, seventh version of the competition. We started very small and internal. The very first version was only Concordia, then OTS joined, and after that we had basically some other university from Canada, and now it's international. It's a pleasure to have a large presentation from all over Canada and the globe this year in the event. I had a few slides just to show, please. I wanted to walk everybody through the procedure of selection, how we receive the abstracts, how we select them, and how we ended up with these basically finalists, the fabulous finalists that we have for today. So we received, from the number of abstracts that we received, 20 plus, 30 plus actually made it to the final round. If you go to next and next, please. So yeah, 23 made it to the final round, and these papers were reviewed internally and externally by several different basically reviewers through some basically analysis criteria that you'll see in the next slide, and 12 made it to the final round. The evaluation criteria is on the board, so it's not only how much contribution to the science and borders of knowledge a work has, but also its practicality and how it can contribute to the industry, the fitness to the areas of interest of AACE, and last but not least, we considered diversity in basically our final round of selections. So I think that's it from me. I wish all the basically finalists luck for this year. And thanks again to the judges, and thanks to the guests. Back to you, Shuruk.
So thank you so much, Dr. Mazak, for those, we like to be transparent and we show everything. We would like first to welcome, if you want to give for our sponsors, actually for Les, to have, you have a couple of minutes to talk about. Yep, please come over. Thank you, welcome, Les.
My time just been cut. No, that's all right. That's all right. Hi, everybody. It's great to see you. It's an exciting day to be here. As just mentioned, this is the 7th year now. Very exciting. I just wanted to say in a nutshell who Techni is as a sponsor. So Techni is a multidisciplinary boutique project management consultancy, a firm. We're specialized, agile. That's why we refer to ourselves as boutique, that leverages hands-on project experience to enable our clients in the resources, power, and infrastructure industries to deliver projects successfully. We showcase this with a theme. Our theme is bringing certainty to capital projects, and that's something everybody wants. Certainty on scope, on schedule, on cost, risk management, forecasting, change management, all of these things which are so important. So we're very proud to be sponsor of the AACE Construction Elevator Speech Competition. We know there's entries from all over the world. It was very exciting. I got a chance to look at the abstracts. The other thing that we're interested in as a company is outreach to the students, right? So the students who will be the next level of project managers, the next engineers, the planners, the systems people, developers, risk managers. This is really important to us because often when I speak at universities, when I tell about the opportunities for students, they can't believe there's such great career opportunities in project controls. So let's speak for a minute about the research. Albert Einstein observed that imagination is more important than knowledge. Now, why did he say that? It's because he was highlighting the boundless potential of imagination in driving innovation and research. It reminds me of the years that I worked with Disney Imagineers. Their expression is, if you can dream it, you can do it. And we know the delegates here today who are going to be presenting have dreamed about their presentations, they've researched them, and we're so thankful that they're here to share that with us today. So wishing you all the very best in your presentations. We look forward to that. And your research today and the ideas you're coming forward with will help make the world a better place, we hope. So thank you very much, and we look forward to your presentations.
Thank you so much, Les. Now, I would like to invite Julie from Canam to give a short talk as well, please.
Hello, everybody. I'm sorry, I just knew 5 minutes ago that I had to talk a little bit. So what drives the Canam is a manufacturer in North America of steel component. We have a lot of products like joist, deck, and many solutions for the building construction. What drives us to be here today is to see what the students the future engineers can bring for us. I'm sure we'll learn a lot today, and I can't wait to hear what they have to say. So, good luck, everybody. Thank you.
Thank you so much, Julie. Now, we'd like to welcome Hajir for a quick talk about AACE. Thank you.
Bonjour tout le monde. Hello, everyone. It's a pleasure to be here. We've been here a couple of times now and always been fondly received by our fabulous hosts. So thank you for having us again back here. It's a pleasure to be here. AACE is an organization, for those of you who may or not be familiar, that really looks after delivery of projects. If I take it closer to my current role, essentially excellence in delivery. You know, we want to make sure projects are on time, on budget, with good quality, happy clients that get the best value for their projects. And that's really all about AACE. You have a whole host of recommended practices. You have a very huge community of practice professionals which are being certified, which learn new things essentially through this association. One of the many. AACE is far from being the only player in that field, but the more, the merrier. Now, AACE Montreal is a branch of AACE International, which has been founded over 6 decades ago. Dr. Maselhi, I think you're probably one of the longest serving members of this, of AACE Montreal. Les has been around for a number of years. I have been around for a number of years, and that reveals a bit, I guess, my age. If I tell you that I've been around for more than 15 years, the last 15 years at least. What we have been doing is to gather the practitioners in town and offer them technical, topics in French and English, host a lot of events, and produce also some technical, articles to the international conference and or locally. So if you happen to be in the engineering field, I think there's definitely a room for you to be connected to AACE, just because it makes you better, it makes you continue to learn, even if you're outside of university. And it gets you connected with a lot of professionals who have been doing that for a number of years. So that's AACE in a nutshell. Back to you, Sharuk.
Well, thank you so much, Hajir, and again, thank you for always being our supporter, actually. Okay, now we would like to welcome Dr. Ma, and he's going to be he's going to talk about the rules, and from there we're going to start afterwards our competition. Please welcome Dr. Ma.
Okay, hello everyone. I'm Jong-Won Ma, Assistant Professor in Concordia University. And I really want to appreciate and echo actually Dr. Master Nikba's speech. So I want to really appreciate everyone for here, including the audience, judges, and sponsors, and presenters, and especially our volunteers who made it possible today. And okay, I will explain about the guidelines and rules for today's event. So let's look for the number of themes. So can you go to the next slide? Yeah, we have 3 themes for 12 presenters. We could divide into 3 groups. So first one is project planning and management digital era. Second one is construction project monitoring and control. And the third one is sustainable construction and operation. So we have 3 themes and 4 papers each. And presentation duration. So each presenter presents 3+1. So 4 minutes presentation followed by 3 minutes Q&A session between judges and presenters. Then how about the audience? Can you go to the, yeah. So we will collect questions from the audience after each theme, which means after 4 presenters are done, we will collect your questions via, we will have a QR code on the screen. So you go with your, access it with your phone and then leave your questions. And then we will ask the questions from the audience at last. And also we'll have the vote from the audience. So we will have another separate award and prize selected by the audience. So please participate in the vote for our presenters, please. And yeah, for example, please access this QR code now and see like how you can contribute to selecting one from the audience award. Yeah, and so Oh, yes. Yes, please access the QR code. So presentation like that.
So, sorry guys, so did you all scan the QR code? Make sure that you keep it, vote after each segment. Now I'm gonna call for our first segment moderator, Minna Hammam.
Thanks, everybody. So good afternoon. Welcome to Theme 1, Project Planning and Management in the Digital Era. In this session, we'll hear from our outstanding graduate students whose research reflects the growing role of digital tools and data-driven strategies in the project planning, optimization, and construction management. My name is Mena, and I'll be your moderator. A quick note, to write your presenter's name on the question paper you will be providing us. Hosna over there is going to give you a reminder for the presenters when they have 1 minute so that we can keep track of time. So let me start by the first contestant, Michael Au. The title of his research is Towards the Automation of Last Planner System. Michael, please go ahead.
Hello, everyone. Thank you. My name is Michael. I'm a PhD candidate at Bournemouth University. And my pitch today is, like Mesh mentioned, towards automation of last planner system. The types of projects that are being taken on these days in construction sector are increasingly increasing in scope and also in uncertainties in scope and also in variabilities. And so also McKinsey in their reports also mentioned that over 98% of the projects that have been taken on these days are either completed late or over budget. And so we must kind of like create systems or planning and scheduling systems in place that is able to help us grapple with these kind of issues. So you can imagine a planner who creates a schedule, and at the point of execution, let's say a look-ahead schedule, and at the point of execution, could not, all the tasks on the plans could actually not be executed because they are not planned for some of the constraints in it. So this highlights the main motivating factor for this particular project. And it tends towards creating look-ahead plans that creating a system which allows us to be able to enable generation of accurate and reliable schedules so as to be able to minimize waste and loss of resources. And for those who do not know what a last planner system is, a last planner system is like a collaborative project control system which engages the last man, right? It's a system which engages the last man, and the last man are like foremen, the contractors, and the supervisors on site, to be able to increase workflow reliability and also improve project predictability. The challenges of both the manual last planner system and the digital last planner system include inaccurate look-ahead schedules. And so that's why there's as an important for automation of last planner systems. And the fact that there are not enough researches in this area, there are no research endeavors in this area. So this particular work is actually looking at automation of last planner systems. And a last planner system is a system that actually, from first principle, it includes the schedule, the communication, and the constraints, right? And so this particular work looks at predicting constraint resolution periods, and so that we can know which particular schedules are actually constraint-free. So we use quite a number of features, such as structural features of the constraints themselves, named entity recognition, keywords analysis, to be able to create the complexities, the constraint complexity score. Overall, we both looked at the optimization of the schedules and also the resolution of the constraint resolution periods. And so overall, this particular research, the result showed that the mean absolute error of the model, of the constraint resolution period prediction model, was 23.18 days of the average instances of the data set. So the data set has a very large disparity of constraint resolution periods, and so the 23.18 days error is somewhat a good prediction model. Overall, this agent...
Sorry, the time is up.
Thank you.
I'll have to stop you, unfortunately, and I'll turn back to the judges. Judges, do you have any questions for Michael? Thank you so much, Michael, for the presentation.
Thank you for the presentation.
Thank you.
What main issue you are trying to address in the last planner system-based solution with your research? How did you try to improve this?
Okay. So, like I mentioned, the main issue is the fact that the look-ahead schedules sometimes are generated about the time at which the project is about to be executed. You find that those particular tasks are not executable because we have constraints on them. So being able to determine how long these constraints would take and to be able to resolve them is an important part of this particular project. And that is what I try to create, a constraint resolution prediction model.
Okay, so then that means that the basic last planner system whereby you go down and talk to everybody and make sure that you get the commitments in terms of schedule to then bring and have more credibility and reliability to the schedule, which already is the solution to the problem that you're talking. You want to improve that, right, by?
That's my solution. And there is not an available automation in last planner systems. Okay. So that's what I did to be able
so
to
just adding the automation to the process that existed. Thank you.
We have time for one more question.
Okay, thank you, Michael. Last planner, the whole concept with the last planner is it's the people who actually do the work, so they should understand the plan. And your exhibit, it showed, for example, there was issues with different tasks. This was unsafe. It had to be delayed and so forth. And what I've typically seen is in the morning, you start, it's a very agile system. You discuss what has to be done today. And that could be one of the points where you detect some of the issues and put that into the system. And then at the end of the day, you might review with the superintendents what was done and what still has to be done. So I see that what you have there is really a supplement to that. It's adding sort of an artificial intelligence to help identify and flag the issues for whatever the reason so they can be rescheduled. Because it's the people who are going to do the rescheduling are the people who are the last planners, so to speak, the people who actually know how to do the work as well. So I see that it's a very useful tool, what you're providing here, what you're presenting or proposing, and it could certainly work. I guess, presume you're doing further analysis on this tool as well in terms of other options.
Yes, absolutely. I mean, for this particular project, I used a multi-stage project that is currently ongoing, and one of our 173 constraints. Although that's somewhat a small data set, so if I'm able to get more data, I'm sure that the model will be able to perform even for all types of projects.
Okay, thank you.
Thanks, everybody. Thanks, Michael. Next, we have Farhan Tanvir Nabil. Farhan, the floor is yours. Okay, go ahead.
Okay, good evening, everyone. We are developing a vision language model-based framework that will automate the process of extracting information from legacy engineering drawing. Now, you may ask why we need to automate this process, right? So, our cities and nations depends on civil infrastructures such as roads, bridges, power grids, and most of the power grids in Canada and 40% of Canadian roads and bridges and 42% of bridges in the US are over 50 years old. And managing these infrastructures is critical, and maintaining, and they require regular inspections, and for that necessitates accurate information of the assets. And the challenge is these assets are, as being decades-old infrastructures, these assets are mostly documented in paper-based construction blueprints, which are mostly outdated and deteriorated. And as engineers and interns, we face this situation where we have to deal with these complex, like overwhelming stacks of complex construction drawings, and extracting data from them manually is very time-consuming and error-prone and resource-intensive. Even the companies hire summer interns to do this laborious work, while the summer interns get paid $50,000 if we calculate yearly, which is very inefficient way of using your talent and expense. That's why we are automating this process by using object detection model, deep learning based object detection model integrated with vision language model. We collected detailed structural drawings from 7 electrical substations, and we are utilizing YOLO V11 version 11 object detection model to accurately, precisely detect and classify different structural elements, geometric and non-geometrical information from the drawings using bounding boxes. And then the images, bounding boxes, and their the detected objects and their bounding boxes coordinates are fed into a vision language model, which is then curated with instruction, which is fine-tuned with curated instructions that so that it generates output in CSV format. This VLM model not only recognizes the characters but also visually interprets to link between fragmented dimensions to specific elements. For example, understanding which heights belongs to which column segment, like that. And then the vision language model generates an output in CSV structured format that we can that can be automatically populated into computerized maintenance management system, creating a digital asset inventory. Our results shows promising promising results and more than 90% precision recall and mean average precision. This framework will help the facility managers in data-driven decision making and proactive maintenance. We project a potential 70 to 80% reduction in manual effort and associated costs. It will significantly reduce the data entry errors, and what traditionally takes months or weeks of manual effort can be achieved within days or even hours. And ultimately, the companies can optimize their manpowers. Thank you.
Thank you so much, Farhan. Judges, questions?
Does this work? Oh, okay. Thank you. Very nice. Thank you. Can you explain to me what would be an adequate level of accuracy for this system, and why? Why is that adequate?
Okay, so as this is, we use this framework for ultimately managing the facilities to conduct asset condition management, so we need pretty accurate data. So we are projecting at least 90% accuracy, because that's when the CSV format, the spreadsheet or the computerized management system will be updated with the data, so that they get the accurate information when they're on site and they're conducting the asset management system, so that they don't get confused that if the information or the height of the structure or the foundation, if they're correct or wrong. So we need, we are at least estimating 90%, 90 to 95% of accuracy.
Great. We have time for one more question.
Okay, I'll follow up then. What is a typical error, and what would be the cost or risk associated with that error?
errors. Okay, so it could be when we use the vision language model, there could be some errors that can, like, suppose we have a column, huge column, it has different segments, right? Maybe in some cases, if the accuracy is not perfect, obviously it won't be perfect for every time. If it is not perfect, maybe a small segment height can be detected as a different height for the, maybe a small segment of the column height is detected as the large segment of the column height. So there can be some discrepancies, but we can use the language model to take the practical example. They consider the practicality of the result or they're generating, so that if it is too impractical or it's kind of wrong, incorrect, they don't update it in the spreadsheet and they send a signal that it's not accurate.
Thank you.
Sure.
Great. Okay, thanks so much.
Thank you.
Our third presenter is Fam Saeed. Please welcome Fam. Please go ahead right away.
Okay, hello everyone. So let's assume for the next minute that I am not a PhD candidate, I am just a salesman, and I have an offer for you. I'm offering you a brand new 2026 racing car, but it comes with one small catch. We have replaced its engine with an old washing machine motor. Anyone would like to buy it? Probably not. That's exactly what the construction industry looks like when we apply all the advanced recent technology like AI, BIM, drones, you name it, without upgrading our scheduling techniques to keep up. So, no matter how shining the outside will be, if the engine is not up to performance, we're not going far. So let's have a closer look to the Canadian construction industry. As you can see, it's facing serious challenges, including project delays, cost overruns, and the most important part, it's contributing to almost 39% of the national or the Canadian green gas house emissions. So most of these construction projects are repetitive in nature, which means whether it's a high-rise building with several floors, or it's just a highway project construction or construction project with several segments, or even just a multiple or a multi-school, multi-bridge habitation project. So we can benefit from the scale of economy. We can benefit from this repetitive nature. But this is where exactly my research comes in. So I developed a multi-mode scheduling optimization model where each task can be executed using alternative construction modes, with each one comes with its own cost, duration, and environmental impact. So my model not only just capture, monetize, and these environmental impacts, but also it integrated it into the scheduling optimization model. So what would be these construction modes look like in a practical life? It could be just using a precast concrete versus just a casting glazed concrete. It could be like choosing between using steel versus mass timber, or even just choosing between using a raw material versus a recycled ones. So my model captured all these environmental impacts based on which construction mode we decide, or which construction mode the model will be selecting, and also integrating that into the scheduling optimization model. Not only that, but also I formulate this optimization model as a multi-traveling salesman problem, which means that all the construction crews act as a salesman, moving around the units to perform their task most efficiently. Now I move to not only this scheduling model can only optimize one objective function. It has so many variety of objective functions. It can optimize the project duration. It can optimize the crew transition time, idle time, total cost, including direct, indirect, late penalty, or even early completion incentives. And also the environmental impact, and not only that, it can combine any types of these objective function and optimize it all at once. And also it can simulate or provide a full simulation for the construction process, where you can know exactly which crew is working where and what's happening in each day in your construction site. with this, and also adding to with a more visualization and chart, it provides a more clear way for the planner, for the project manager to provide a more effective, sustainable, and accurate and cost-effective schedule for the construction project. Thank you.
Thank you so much, Fam. Judges, please go ahead with your questions.
Have you been able to run some pilots and measure some efficiencies that you've gained because of this?
Yes, I did a couple of case studies compared to literature reviews, models, and I have gained like around, on average, in duration, in project duration, a savings around 20, maybe to up to 50% less duration for the projects.
In the model, great.
Yeah, but nothing in real life because we lack data to run Tasya model.
No, that's fine.
Yeah.
Thank you. Thank you.
Okay. Any more questions?
Based on your experience, what would be the next step to integrate this with a commercial scheduling system?
Well, this is my next step after I finish my PhD.
But how? What is the next step? Oh,
Well,
you can't tell us. Is that corporate?
So I'm planning to submit a patent request first because I am using some novel constraint representation for this scheduling optimization model, and then I'll take it from there.
That's the first proprietary knowledge answer I've ever got. Thanks.
Yeah, very nicely presented. In this case, this would be like a general contractor situation. For example, you talk about moving resources around, crews around. That's fine for a general contractor. Often we're dealing with multiple contractors who have their own crews, and so the idea would be rather limited about being able to move crews around unless it's general contractor.
Yeah.
The other point you made, I just wanted to ask a question. You talked about the sourcing of material. If it was going to be reused, recycled. I mean, this is largely done on the front end of the project, right? Those decisions are made. It's usually not something that happens during the actual execution. This would be part of the planning. Am I correct?
I would say partially yes, because if you have a certain amount of details, you still can use this model to give you like, you even can use it in the planning phase. You don't have to wait until you have all the details, all the bill of quantities, so you can run it.
Right.
So it ranges between a very high details, like using work packages, kind of general data for the project, or even you can use it with the exact data for your project. What task, what kind of bill of quantity you're going to use it, what construction mode you're going to use.
Right.
So,
No,
yeah.
I understand. And changes can happen. Sometimes the change would be good to make a change even during the construction if it's going to reduce schedule, if it's going to impact, save money as well. So thank you.
Yeah, welcome.
Thanks, everyone. Thank you so much, Fram. Last but not least, we have Yubin Jean. Please welcome her. Okay, please take it away.
Good afternoon, everyone. I am Eunbin Jung, a PhD candidate at International University in South Korea. Today, I will present about a dual approach of precast concrete installation time prediction. In precast concrete, which we call PC construction, accurate installation time prediction is crucial. Currently, there are two methods for PC installation time prediction. First, the field manager's experience-based method. It assigned fixed times like 20 minutes per or beams. This fails to consider variability. Second, the machine learning method. It predicts only ideal conditions, so this fails to consider work interruptions. My solution is a dual approach that addresses both issues. First, it uses machine learning to predict base duration. Machine learning is perfect for this because these patterns are repetitive and predictable based on factors like component type, weather, and location. Second, it uses Monte Carlo simulation for work interruption duration. These are These are unpredictable disruptions. Monte Carlo simulation is perfect for this because work interruption events are infrequent, random, and diverse. By combining both methods, we get the total duration that reflects real-world complexity. Let me show you the comparison of three methods. Experience-based method gives a single value, leading to high error risk. Machine learning provides point estimates but missed work interruptions. It contrasts proposed method produce distributions showing the full pictures of what can actually happen. The benefits of dual approach are significant. First, it provides a complete pictures by combining ideal conditions with work interruptions. Second, it visualizes uncertainty. Third, it enables informed decision because managers now know both best and worst cases. Proposed dual approach transforms uncertainty from a problem into manageable information. Thank you for listening.
That concludes the presentations for theme 1. Now it's your turn. We invite you to scan the QR code, decide on who you're going to be voting for this theme, and please make sure that you vote for only one contestant in each theme, and you vote for all the themes. Thank you again for all the presenters and the judges for this excellent start to the competition. Now I'll pass it over to Ihab, who will take care of theme 2.
Thank you so much, Minna. Hello, everyone. Welcome to the second theme of AACE Construction Elevator Pitch Competition centered around construction project monitoring and control. This is Ihab Al-Husari, a PhD student at Concordia University, working under supervision of Professor Sam Salhi, and the planning director of AACE Committee Montreal section. It's a great pleasure to be the moderator of this session. So in this stream, presenters will showcase their research on project construction monitoring and control, aiming to enhance different kinds of key industry challenges like research management, structural integrity, dynamic object tracking, and material delivery using different kind of technologies like computer visions, integrating sensing systems, robotics, and other innovative solutions. So we're going to start with the first presenters, but I just, before starting, I want to remind you, everyone, at the end of this session, you will have the opportunity to vote for your best presentation. And also, we're going to collect the question from the audience. So please write down your questions. So now we're going to start with our first contestant, Mohammed Sabik. So please welcome Mohammed Sabik. Hello. Hello, Mohammed. How are you?
Good.
Are you ready?
Yeah.
Okay. So you have 4 minutes, and your time starts now. Oh, go ahead, please.
Hello, everyone. My name is Mohammed Sabik. I'm a PhD candidate at the University of Alberta. Today, I'm going to present our research to you. I want you to imagine this situation. A construction worker fall from a ladder on the construction site, goes unnoticed, or a fire hazard start anywhere and again goes unnoticed. Unfortunately, similar events keep happening on a daily basis on construction sites all over the place. It's not like randomly. These things happen and impact people's lives. It can even sometimes shut down whole construction projects or increase the budget by $1 million if the insurance claims start to be a thing of the construction situation. So this is the problem statement that we're trying to focus on, is the safety issues within construction industry. Unfortunately, construction industry have one of the lowest efficiency rates all over the other industries, like manufacturing, agriculture. We're having very low safety rate comparing to other ones. The other thing that we are focusing on in our research is this graph, which shows the productivity estimate for construction industry in the last 50 years. Unfortunately, again, we're having a very steep, sometimes declining performance index comparing to other major industries, especially relating to something like manufacturing. This situation creates the kind of industry that we are having today. It's not efficient that much as we would like to have. It's not safe. And there is a major room to improve things. So here it comes, the solution that we are proposing. In the last 2 years, we have built a foundational computer vision database that consists of 90,000 images, manually annotated, picture by picture by our team. And this database is going to be the foundational framework for computer vision models and VLMs to be implemented into monitoring the construction sites. As you can see in the video that is rolling on the screen right now, this is one of the models that was trained in our foundational dataset, which we call it CVAD. And this model is capable of detecting more than 50 different classes within a construction environment. We're talking about classes like different kinds of construction equipment, human beings, PPEs, materials, safety incidents, events themselves, and other things. The list is long. And as you can see here, the model is capable of detecting the classes.
1 minute left.
And tracking all the equipments, identifying the busy zones, identifying if any safety incidents happen. And out of all of this, gives us, the sky is the limit for the kind of outputs we can get. We can increase the efficiency, we can save people's lives, we can identify the weak points or the inefficient processes in any construction site. Basically, to conclude, we're trying to give construction sites monitoring systems eyes with an accurate estimation to each thing happening within that environment. Thank you very much.
Great, Mohammed. Under the wire by 20 seconds. Great presentation. So now we're opening the floor for judges to ask their questions. Do you have any questions, or judge?
Please.
You have you actually tried this in any of the actual sites in dealing with unions and the privacy that has to be taken into account?
Yes, we do. Right now, we are working with multiple partners in Alberta. The first problem that we faced, that the privacy issues, people didn't want their faces to be monitored all the time. And because we are using such customizable framework, we've been able to anonymize everyone's faces automatically. It happens automatically. No one is involved in the process. And that gives so many people, the unions, the subcontractor, huge relief of knowing that the camera is already in everywhere, but having that kind of AI monitoring into the equation start giving the people the thoughts, I'm being monitored all the time. But yeah, that was a problem, but we have addressed it with multiple partners, and that right now we are testing the system with multiple partners without any issues.
Thank you.
For safety, maybe you could just talk a little bit about this AI-powered vision as to what it's showing us right now. It's in blue, it's showing us repetitions or repetitive work. How does it work, this vision system that's set up?
So for the safety things, what I mean is that if someone falls on the ground right now, using our system, we implemented hybrid technique, not using only object detection models, which is the norm in such situations. We're using also a VLM models that we fine-tuned using our own dataset. Mm-hmm. That VLM is capable of detecting safety issues, like someone fall on the ground, as a fire hazard start to appear, a smoke start to appear from somewhere, if there is an oil on the ground. Or in that situation specifically, if there is some cracks on that hill, we can detect that. Because VLMs is really good is something called zero-shot detection. And zero-shot gives them the ability to understand situations and detect situations that even they didn't train for.
Okay, so I would think this computer vision zooms in if there's an issue or an area, a problem, that will zoom in on that point.
Yeah, exactly. We're gonna take, for instance, if someone fell in the ground in this location, a screenshot will be detected, like a closed one. That screenshot will be sent an email or like a notification to the safety officer, the project manager, anyone involved, so they will know that that happens. The good thing about this system, actually, we're trying to identify near misses, the safety incidents that usually happens in a daily manner, but it goes underreported. With these systems, we can detect these situations and prevent them in the future.
Okay, thank you.
Welcome.
Okay, thank you so much, our judge. So thank you, Mohammed. Okay. Unfortunately, our second contestant, Mohammed Rizul Karim, apologized at the last minute. Is not able to come. So we move forward with our next presenter, Jaimin Shin. So please welcome Jaimin Shin. Hello, Jaimin. Are you ready?
Yep.
So please go ahead.
Good afternoon, everyone. My name is Jaemin Shin. Today, I'd like to discuss a methodology to integrate the multiple vision platforms on construction sites through a unified 3D map for digital twins. Various vision platforms are being utilized to manage the construction sites using their own strengths. For example, terrestrial laser scanner is largely used for structure inspection because it can generate high precision model of the structures. And UAV can produce rapid and wide view of the site, which makes it ideal for overall site mapping. And CCTV can capture continuously time series data. This is very useful for some tasks like productivity analysis over time. However, these vision platforms also have their inherent limitations. TLS is very slow and requires manual operation, so it's not practical for large-scale site mapping. And UAV is usually deployed in high altitude and produce top view of the site. So it have low resolution and miss vertical surface. And CCTV has limited view and is prone to the tracking errors, especially in complex scene. To address these problems, I propose to integrate these vision platforms through a unified 3D map. First, UAV can generate the overall 3D map of the site, and TLS refine the key structural elements with their high precision model, aligning with the UAV-based 3D map. And finally, CCTV can detect and track the moving object and give the dynamic information into the 3D map for robust object tracking. In experimental results, a site in Seoul National University is chosen as a testbed for map refinement and object tracking. As you can see on the top right, our TLS-based refinement successfully recovered the vertical surface of a building and refined the details in structure. And below that, our proposed spatial-aware object tracking successfully handled the duplicate among the multiple cameras and interpolate the track failure, enhancing the reliability of object tracking. And here's my direction for future work. First, I will develop a system for simultaneous object tracking using multiple agents. And second, I will implement incremental 3D map updates for real-time reflection of the current status of the site. And ultimately, using these developments, I will realize digital twins for real-time and data-driven site management. Thank you for listening to my presentation.
Thank you so much. Thank you, Jamie.
And I have some time, so I will explain my contribution. First, I successfully implement the framework to register the UAV and TLS map, and it's fully automated process, and it also have very accurate results. And I also implement the object tracking method, which use the spatial context to increase the robustness. And I lay the groundwork for digital twins because digital twins require the pipeline that use the...
Okay, Jamin. Sorry, the time's over.
Thank you.
Okay, so now our judge, do you have any questions?
Yes, thank you, by the way. Interested about the digital twins, realized digital twins reflects real-time on-site conditions. Are we talking about progress measurement here, or the objective of having this data, tracing this data, is it for tracking progress, or what's the ultimate purpose?
At first, it only tracked the position of the dynamic objects, but after we implement the accurate object tracking, we can add some dynamic information like the activity analysis and like that. So yeah, we can extend the usability of the...
Right, so you're using sensors and other methods to measure this, the 3D map, to create the 3D map. You're using sensors, you're using other ways as well, not just the video, but sensors to determine this. Okay, thank you.
Any other questions? No? Okay.
All right, thank you very much.
Thank you, Jamin.
Thank
you
you
so much. So now let's introduce our next presenter, Tianu Ren. So please welcome Tianu Ren. So please go ahead.
Okay. Hello, everyone. I'm Tianu Ren from University of Illinois Urbana-Champaign, advised by Professor Houghton Jebeli. So today I'm excited to present my topic about autonomous drone system for attic inspection installation in hazardous spaces. So why we care about attic? Attic is a major source of heat loss in your home, and it is important for energy efficiency, but often get overlooked. This is a manual process, highly labor intensive, and inherently dangerous because of heat stress and falling risks and poor lighting conditions. And also, there's a big economy opportunities here. The market is over $10 billion, and with automation, it can significantly cut the cost and protect our workers. However, there are some key challenges here. First, the system needs to be compact and agile in confined space. Second, the perception needs to be reliable in detecting the insulation defects and structures under poor lighting conditions. For navigation, it should work in this GPS-denied cluttered space, and that means a real-life localization and obstacle avoidance for safety issues. Therefore, we developed an integrated drone gripper robotic platform here. First, we designed a drone with a robotic gripper, which hold a hose to spray the insulation materials. Then we have a thermal visual perception engine, which uses a convolutional neural network to track the insulation conditions. And we also incorporate simultaneous localization and mapping here with the LiDAR data to reconstruct a 3D map of the environment. After that, we have our autonomous navigation system, which we start from a grid-based navigation system, gives an initial estimation of the path based on the map. Then we refine this path using reinforcement learning network based to adapt it to any environmental changes. Then the result from the experiment looks promising. So first, we have 96% mapping intersection over union, which means our map is a close representation of the real environment. We also have 90% classification mean average precision, which means our system can differentiate between different elements. And for navigation, we have a 95% success rate, which overpass many state-of-the-art methods. And our solution is also have a collaboration success rate of 92% with human workers, where our system can predict the intention and movement of the workers and collaborate with them. So in conclusion, our system have both practical and technical contributions. For practical contributions, we provided a solution to automate attic installation work, and which is a safer, cost-effective, and more efficient way. And for technical contributions, it goes beyond attic installation. First, we have a perception module that allows the drone to perceive the 3D environment and build the 3D map, and also recognize different elements in the environment. For navigation, it ensures both efficiency and adaptability, which outperforms many existing methods in indoor construction environments. And we also provide a solution for the drones to collaborate with human workers, like for the drones to estimate, predict the movement and intention of the human worker to allow the drones to work in close range with these workers. Therefore, this method paves the way for a safer and automated construction operations in the future.
Thank you,
broadens
Tammy.
the applications
Thank you.
of drones.
Time's over. Thank you. Now our judge, do you have any questions?
Thank you. Very interesting topic. When you talk about that collaboration, can you offer an example of two of those collaborations that the drone helps the worker?
So for now, the collaboration goal is to avoid collision. That's the first thing. And in another scenario, the drone need to collect some tool from the human worker. So in this example, it shows the drone to avoid collision with the worker. So we can see that the worker is kind of bending down, and so we can predict its kind of movement and the intention of different body postures. And then the drone can avoid the movement, like the intention, the intended trajectory of the worker, and then kind of collaborate safely with the worker. That's actually beyond just the application in attic installation. That can be used in many different applications.
Have you considered any application to improve the efficiency of the work with the help of the drone?
Yes, so attic installation is my first kind of application scenario. So we are also working on like surface finishing for now, like elevated surface. That's another good application for drones. And also we are doing some different end effectors. Like for now we use a hose, but then we can use a rotating disc to do some flattening operations like that.
Okay, thank you very much.
Thank you.
Fascinating. If you were in an attic that was 38 degrees Celsius, would the human be visible using infrared?
You mean using infrared?
Yeah.
Actually, currently our body posture recognition system need a camera to recognize the body posture of the human.
Thank you.
I think the infrared, that is effective in identifying the insulation material kind of thing, but human is more dynamic, and I think a camera.
That makes good sense. I was just confused by the image. It looked like an infrared image of a person.
Oh,
sorry.
This is his trajectory of his movement, like his intention when bending down.
Thank you. Okay.
We still have time if you have any other questions.
Okay, one last question, quick. What happens when the drone crashes?
Well, that's why we try to avoid that. So we start our experiment in a controlled environment, obviously, and then we move into real-life experiment with very careful because of that problem.
Right, and it will crash. So what is the solution?
So first, our drone, now we use a compact drone, which is a small drone, and they are not moving with a fast speed. So we control the speed, we control the size, we control the payload to make sure the kind of, if anything happens, it's kind of in a lowest impact.
Okay, thanks.
Okay, thank you so much, Tiano. Thank you so much, our judge. Now it's time to vote for your best presentation of this theme. I can kindly ask Atifa and Shaheen to collect the questions from the audience. So thank you so much, everybody. This is the end of the second stream. Now I'd like to pass the floor to my colleague, Azada. So over to you, Azada, to moderate the next part. Thank you so much.
Thank you. Sustainability is no longer a trend or a buzzword. It is our shared responsibility. As we all know, construction industry is one of the most resource-intensive industries, and it is time for us to take real actions. The choices we make today on how we design, build, and operate will shape the future of our environment. In this session, we will hear from the presenters fresh ideas and innovative solutions to make construction and operation more sustainable. Let's start with our first presenter, calling Karina Kwan. Karina, the floor is yours.
I can start?
Yes.
Yes. Good afternoon, everyone. The construction of unembodied carbon contributes significantly in the global carbon emissions. In COP26, it just called for a net zero embodied carbon in new and existing buildings by 2050. How can we achieve this? The answer is money, linking the carbon emission to the money. However, we have different challenges. Banks worry about the data tampering, limited data access by the public. Contractors have a concern about the data traceability. Also, suppliers have the data privacy concern as well. We try to navigate the blockchain can help. Don't think it is a complicated process. Just consider it as a database with a immutable, traceable, and transparent features. My research aims is to navigate blockchain technology to enhance the embodied carbon accounting and reporting, and linked to the green finance mechanism to incentivize embodied carbon reductions. The system consists of the traditional management system and a public blockchain database. In the public blockchain level, it first uses the hashing function, something like the unique data footprint to secure the data integrity. Second is to try to use the cryptographic techniques like a verifiable trail for the data traceability. With a public ledgers, once the data upload, it's open and shared to the public. On top of this, our system also integrates with the hierarchical hashing function for the verification process, try to ensure the data integrity before on-chain, and also the selective data disclosure approach for privacy preservation. Finally, is the role-based control access for the blockchain adoptions. We also developed the functional prototype. In the prototype, we included the off-chain data input and validation, as well as on-chain quantifications and recording process. Apart from verification, the evaluation also include the validation, which assess the system performance, usability, effectiveness, as well as the industry impact. For the contribution is in the green finance. Green finance tools include green bond, carbon trading, green loan. The proposed system provide more accurate and transparent data to support the green finance activities. As a result, the project team gain access to the more capital that can be used to select more green material, greener site activities, and greener transportation mode. And in summary, my research is to propose a novel blockchain-based system to enhance the carbon data in terms of accuracy, traceability, transparency, and privacy, as well as links to the green finance for the upfront and embodied carbon reduction. Thank you.
Thank you, Karina. Judges, do you have any questions?
I understand that you've spent a lot of energy on the security piece of the solution to make sure that everybody trusts in the system. What will be the advantage of using this system compared to the commercial solutions that are available out there currently? What is it that you're offering more than what is out there on the market?
Sorry, may I beg your pardon?
So there is other solutions, right, for now for exchange of carbon, credits in the market. What is it what advantage your system has over what is already being used in the industry?
I think based on my at the beginning, we try to interview the stakeholder in the market to identify their concern, because when we try to reach out for the bank, they got really concerned is whether the carbon data from the project team or from the developer is accurate. They always worry about, because it related to money. And once it related to the money, the carbon data become very, very important in terms of accuracy. So my system tries to ensure the first thing is the data integrity, because in the whole supply chain, we got the different data from different parties. So the traceability is another very big issues. So we try to use the, as well as the final thing is, because in the current existing upfront and embodied carbon accounting, usually the popular one is missing because they just show something like the good data, and you're just having the greenwashing problem. So because when we're using our system, it can first ensure the data integrity, trace all the data along the construction supply chain, also including the popular party in the system.
Thank you. Thank you very much.
If you don't have any question, we can proceed with the next. Thank you.
Okay, thank you.
Thank you, Karina. We will continue with Golnaz Mirzai. Golnaz, the floor is yours.
Hello, everyone. Thank you for being here. Today, I'm going to present my research by answering three main questions: how, what, and why. So first of all, why this topic? Environmental challenges is not something that we can ignore anymore. And construction industry is one of the key contributors, is also responsible as a big solution. So moving towards circular construction and using materials as long as possible is one of the best ways. And reusing structural components can be one of the valuable options, as it keeps material as they are as long as possible with the least amount of processing. As a result, it will reduce the carbon emissions and environmental impact even further, comparing to other options like recycling. But of course, it's not that simple. There are many challenges to reuse, like costs, like complexity of working with these reusable components, and unavailable information on the reusable components. So moving toward addressing these challenges, designers play a key role. They are used to a traditional, straightforward way of processing, which starts with designing the geometric, then do the structure analysis, followed by member sizing, all based on an unlimited supply of components. Now imagine telling these designers that you have only this limited stock of elements. What will happen is that this process becomes a frustrating trial and error that they're trying to fit these reusable components into the design and adjust the design so that it works for the components. And to simply put, they won't do it. So let's go to the next question. What can be done? The idea is to change the way that we design. Instead of trying to force the reusable components into the design manually, we can make a system for it and let that system to do it in a smart and automated way. In this way, the designer only needs to set the design boundaries, like the loads, the supports, even the span, even the symmetry conditions, or whatever that is important for them. And then, as well as the reusable components inventory, and let the system to take care of the rest. The system will explore thousands or even hundreds of solutions, and it will find the design that has the least environmental impact. Also, it's feasible, and of course, it meets all the requirements that the designer wants. So let's move to the most important question, how this can be done. What we are proposing is using generative design powered by genetic algorithm. In this process, it starts with generating a set of random population and then evolving them through the other generations till it gets to the best solution. In this figure, you can see what will happen in each generation. It includes improving the topology and geometry, followed by structural analysis and member sizing, just like real engineering, and then matching and replacing these new components with reusable components, and then assessing them based on a score that we define, and it's a function that reflects waste, environmental impact, and even cost. So in a case study we did, in a simple steel wire and truss, 56% was achieved on the reduction of carbon emission and 64% in energy usage. So all we are saying is by rethinking how we are designing, we can move toward removing the barriers of reuse and also making circular construction not just achievable, but the new standard. Thank you.
Thank you. Does your system allow for cutting of components?
Yes, it does, and but it tries to minimize the cutoff waste so that it would be less waste and it would be more efficient. The design would be more efficient.
Thanks. I'm wondering what are the inputs of your systems to allow the designer to change the brand new beam, for example, for a reuse beam?
Sorry, can you repeat your question?
What are the inputs of your system to allow the designer to choose between a brand new beam and a reused one?
Okay, so I think you're asking that what can be, like assessing the design would be based on what? Like the matching, what factors are considered in matching the new and reused components. So it can be based on different criteria, which is important for us. Like it can be based on the functionality of the component that we have. It can be about the location of the component that we have. And also it can be about the size and like how big it is from the component that we need, how big it is, so as it is its closest, it's better. And it all are reflected in the function that we develop for the system.
Thank you.
I'll do one quick one. Is there an assessment that needs to happen on the reused material just to make sure that they are good to go for another 20 to 30 years for any fatigue or any other elements that may affect their usability?
So this can be another step, which would be on the making this stock and make the reusable component inventory, but this can be something that considered as well.
Yeah, just a quick one. The material passport, where does that fit into this process, right? The material passport. How does that work and how is it involved in this?
Yes, I think the material password would be considered in, again, defining the inventory so we can see that how much CO2 emissions this, like for example, this element has, or the cost, or sorry, the cost, no, the CO2 emissions or the energy usage, it can be considered in that stage.
Okay, and I guess the other question is anytime there's a change, there's resistance. How do you overcome the resistance to change and to design differently?
I think by integrating these kind of research into the softwares and in the tools that the designers use, they will be less resistance because it would be easier for them to move toward using this kind of thing instead of forcing them and make their life harder.
Okay, great, thank you.
Thank you very much, Golnaz. We will continue with our third presenter, Mohammad Ehsan Tabatabai.
Hello, everyone. Good afternoon. I would like to start my presentation with a quick example. Just imagine a new hospital buildings. As far as it is in budget and in schedule, we call it success. Even if no one counts the tons of CO2 released to the air by implementing traditional method where it was not necessary. This blind spot may explain why construction industry often called a slow adopter of innovation. Hopefully, public project owners of Quebec wants to change the story. They asked and told us they need a solid proof to show that innovation can deliver true values. We do believe that advancing innovation requires measuring its impacts it delivers during the whole life cycle of the project over time. Hopefully, this project is granted with a couple of $1 million. And my thesis is focused on the various initial step, where to assess what they have in place to track their performance, what they are looking for, and what are the challenges they are facing to. And finally, they want us to give them a solution to improve their decision-making process to adopt innovation. To do so, we propose this conceptual framework which captures both performance measurement realm, the traditional measures that we have in place in many organizations, and also more longer term effects, which is called impact measurement realm. Why it is matters? Because if you just focus on the construction phase, that is to say performance measurement, you may miss huge gains or huge loss that appears afterward. So, for example, energy consumption during the construction phase is really tiny to compare with the total energy consumption during the whole life cycle of the project that afterward in the operation phase that may last for 100 years. So we do believe that to capture all the things we need to address whole life cycle. So we had a chance to have interviews with professionals who captures and set KPIs to set KPIs and monitor KPIs with 5 major public project owners of Quebec, who together manage more than 80% of construction costs in Quebec. So we had a chance to do the qualitative data analysis and answer what is being measured, how it is being measured, and why it is being measured for both current practices and their future needs. So finally, we could had some follow-up workshop with 5+1 public project owners to validate and ask them to rank each KPIs with its importance and also their usefulness. So we have a list of KPIs candidate for next step, which we'll implement in 3 pilot projects. So finally,
time is over.
So it's okay. Thank you.
Thank you. Do you have any questions?
Hi, thanks very much. KPIs are key in project reporting, there's no doubt about it. In your research of those KPIs that you've got on the board, which ones were the most, had the most gravity, had the most, weight factor, biggest weight factor for your research?
Of course. Yeah, you're absolutely right. So basically, what we have in place with 5 major public project owners of Quebec, cost and time KPIs are still dominate. That is to say, I will present all these results in the conferences, but yes. What I can say that they are only focused on time and cost, and just a few of them looking for safety, where that is kind of interesting.
Well, safety, that's true. Yeah. Safety should be really at the top of the list in terms
but it
of
was
KPIs.
not. Surprisingly, it was not.
Yeah, cost and schedule, I understand. You've got earned value management, cost index,
exactly.
Schedule, performance index. That makes a lot of sense. Okay, thank you.
But hopefully, we are addressing more sustainable KPIs. There is a need there to address more list of KPIs.
I do like the fact that you've identified scope and scope change, because that is a major torpedo in many projects, right? It sinks a lot of projects. So at least it's made the list of KPIs there.
Yeah, there is 5 there. Change order, both for client initiated and contractor initiated.
Okay, good. Thank you.
No worries. Thank you.
Did you compare this to any of the other jurisdictions' KPIs? Are there where there is more emphasis or they're more advanced from sustainability point of view? What other KPIs are others looking at beyond cost and schedule?
Okay, yeah, if we go through it, the literature, we listed more than 42 KPIs. So from the insight that we have from the interviews, we listed 42 KPIs. Then through workshops, the project owners give the importance and usefulness of those. So we went through many frameworks, but the last thing that we have is this conceptual framework, which we have 9 groups of KPIs. And for their needs right now, they are addressing only 17 of those. Because for the conservative and mature project owners, it is hard to adapt new, innovative things. So they are only looking for only 2 or 3 main KPIs. So if you want to go through everything in one shot, so maybe it's not a good approach.
Thank you.
Thank you.
If you don't have any other question, we can proceed with our final presenter. Thank you. Thank you, Ethan.
Thank you so much.
Our final presenter is Dylan Dermos.
Thank you. Can I ask you a favor? It's already here. It's not updated. Okay. I just updated my presentation, but fine. Hello, everyone. I'm going to talk about knowledge. When I started my PhD, I did a literature review to understand the challenges and gaps in facility management, and I see that the biggest challenges are happening because of the knowledge gap between people and the processes. Then I wonder, what is knowledge? And if we ask this to Socrates or Confucius, they would say that to know is to know that you know nothing. That's the meaning of true knowledge. But in the 21st century, this logic doesn't work for us anymore. And so we are following Francis Bacon. He is saying that knowledge is power, and that power comes with a structure. So data, when we put the data together, we reach information. And when we put the information, contextualize the information, sorry, also I want to show you. And when we put the information together, we reach knowledge. And from that knowledge, human tries to reach wisdom. And, sorry, when, I'm so sorry because the presentation is not as expected, updated. And from there, human expect to reach wisdom to make good decisions. But where do we get that knowledge? The most importantly, how do we get that knowledge? Data is everywhere. And we have the tools to put the data together. We have tools, software, automation, but with the traditional tools such as expert systems, they are too rigid and they are making too much challenges for us. Then I thought that we need innovation. We need innovation. That's where my research comes to play. I'm exploring the most excited recent developments in AI, which is large language models. To test large language models for facility management, I chose fire safety management as a domain because fire safety management is the most challenging field which accepts zero tolerance domain. Because LLMs are powerful, yes, we know that, but they come with the inconsistencies, they make too much hallucinations, and they're unpredictable. They even lie to us, very confident to lie to us to convince us they are correct, they are telling correct information. And I also realized that during my experiments, prompting is very naive, and it is not helping us to understand black box structures of the LLMs. So, I propose a hybrid knowledge engineering methodology, which puts AI in the decision-making loop, and it guides LLM into sound and useful decision-making processes. Think of this: explicit construction knowledge is easy to imitate, but tacit expert knowledge comes with years of experience, and that's harder. My research investigates if we can use LLMs to extract and generate knowledge of a chief manager who is walking that building for 20 years. I can say that the answer is not in the tool, but in the information flow of the tool. We need frameworks, not just prompts. We need conceptualization, operationalization, formalization, that are the core steps of the established knowledge engineering methodologies. AI is not here to replace us. So my research lays a foundation for not just for automation, but innovative and responsible intelligence-built environment. Thank you so much.
If you have any questions.
I can't keep up with AI, but is this part of the fourth wave reasoning AI? Is that part of what you're trying to do?
Yeah, this is the new AI. I'm working on neurosymbolic AI, which is large language models. So you are right, after this AI winter, it is quite challenging and it is very skeptical to believe in AI. Of course, also, I'm not saying that AI is there and we can trust AI fully. I'm just trying to understand at what point and at what extent we can integrate AI in decision-making processes. And yeah. And we are seeing that, yeah, it is just there to help us, not replace us. Mm-hmm. Thank you.
Yep, just a quick question. I mean, you've made a very good point and description how to collect data. Data is everything. It's like gold today, right? Our data, but it's getting the right data. Now, this model, fire safety management as such, what is the final outcome of that? Because fire safety management is about how to detect fires, how to prevent them. So there's a whole, where are you in your study regarding the actual results of the data?
Exactly. Thank you for your question. At this moment, I'm doing a passive experimenting with fire safety management. Of course, it is not real-time data. I don't work with IoT or sensors. But now we are working on the existing fires that are reported previously with the fire safety experts, especially NFPA. I'm working on it. And we are putting the data, for example, the narrative of the building, 2D plan of the building in an AI tool. And I'm working on the chain of agents. And from there, we are structuring data to see at the end if it is giving, it can be preventive emergency, or it can be like occupant evacuation. And we are seeing if the decision, the output comes from the AI is matching with the reported experts' results.
Okay, very good. And that would tie in with, fire risk assessments, prevention strategies that would result from that. So I think it's a very good objective. I think if we could also do the same for forest fires, that would really be good for us in Canada, because it's a big problem these days. No, thank you very much.
Thank you too for your questions.
Any other questions? Thank you, Dilat.
Thank you so much for your attention.
With the conclusion of the presentations, we officially close this part of the event. On behalf of AACE Montreal Section Student Committee, I want to thank our judges for undertaking this crucial role. And also, I want to kindly invite you to first go and help yourself with food, and then take your needed time to finalize your decision about the winner. Thank you. Also, audience members, please, through that QR code, just submit your votes, because we have a winner from the audience too. And also, meanwhile, the judges make up their minds. You can watch the video from AACE.
Innovation, research.
The superstars of the event. And the Oscar goes to
5. Bond 5.
Risks to innovative approaches.
We can announce without you. Okay, so can I invite Dr. Mazdak now to announce the winners? Please.
Thank you, everybody. So before anything else, I want to ask you to join me to thank the volunteers who made this happen, first and foremost. And also the Montreal section, the Students Committee for AACE. All right, that time of the event again. We don't have drums yet, no? No, not even, thank you very much. Okay, so let's start with the vote of audience. Is that the right order? Someone has it on, okay. So let's start with the vote of audience. This is number 7. We don't have 7 winners. We have only 3 winners and a vote of audience. So the vote of audience went to Gulnaz Mirzai. Congrats, Gulnaz. All right. Now the 3 main winners. Let's start with number 3. The third winner of 2025 3-minute thesis competition is Tian Yu Ren. Come forward, Tian. Congrats. Number 2. The second winner goes to Pham Said from University of Waterloo. Okay. The last but not least, the drum. Maybe it's the time. So the number 1, the top winner of 2025, the vote of the judges is Gulnaz Mirzai. Gulnaz, come forward. All the 3 of you. Okay. So maybe now we can listen to the judges for like a couple, basically, key points on the presentations, the event, the winners, the ones who were not selected, anything that you want to mention.
I'll go first. Yes, I would only repeat the message that you said. Thank you very much. I know there's a lot of work that goes into this every year, and this year I think you guys delivered as usual. So thank you very much for that. it is it's a nice change to see everybody present in person in front of you. So that's an extra challenge for those of us who are maybe used to be behind our screens and put the headsets on. So that's extra kudos to you for being here and presenting. I especially liked the three of yours speeches. And I think if this is any representation, this probably tells me that this is not about the language. I know your first language is not English, and that does not matter. What matters is that you'll be able to simplify the question, simplify your solution, and be able to answer the questions, I think, in a succinct manner. And I think you all delivered that, and congratulations to you for that.
Thank you very much, Ajay. On that, you're in Quebec. Nobody's first language is English, so don't worry about it. Okay, maybe next.
Congratulations all.
I really can't add anything. Congratulations. Yeah.
Yeah, I want to thank everybody. When I look at when I read through the abstracts, I saw such different topics which were very topical, I should say, with machine learning, digital twins, and important topics like safety and recycling, green engineering. So I found there was quite a variety of topics here that we could relate to in our business, and certainly we talk about as well. And I think your presentations were very smooth. You looked at us directly in the eye. You spoke to us. And what's really important, I think, is when you do a presentation, and that's for everyone, think about your audience. Think about these judges who maybe have just heard about some of the things that you were talking about. So make it really clear for us what as you did. It was like, this is what I'm talking about, who, what, why, where, and when, and prompt us so that we can then follow it and then come back with more questions. So I think it was extremely well done. This is the first year it's been face-to-face. So that was different. I think when you're sitting at home in front of your camera is sometimes a little bit more confidence, You don't see the people, so to speak, directly eye to eye. So it was a big challenge, and I think you really rose to the challenge. So thanks, everybody. It was an excellent experience and a terrific event for Concordia and AACE. Thank you.
Thank you. And I think special thanks goes to the 4 fabulous judges. Thank you so much for your time, for everything that you've been doing for this event over the past few years. Couldn't have happened without you and your help. So maybe at this point I can ask Dr. John Wang Ma to join me. Yeah, don't sneak out. Just come forward when just take pictures. The winners will be announced in the gala, so we will let the world know who the winners were for this year. Just a fun fact is this was not the first time in person. This is the 3rd time in person. So the first 2 versions were also in person, but as soon as we went international, we couldn't do it in person. So this is the first in-person international version. It's a big thing. So kudos to the 3 of you. Congratulations. John, do you want to say anything and close this, or we should take it from here? Okay, thank you so much, everybody, for your attendance. May I ask the judges to join the winners, and we take a few pictures, and also the committee. Please come join us for the figures. Everybody else, continue enjoying your evening, mingle, and there's still food and coffee left. Enjoy your evening. Thank you so much for coming, and see you next year.
Thanks, everyone, also for joining us online. We're going to be closing up that Zoom and the live stream now, but just let you know, this remains available on our YouTube channel, and you should revisit. You should watch it. Okay. Thanks for joining us.